Hi, welcome back to Allen High School's discussion of chemical reactions at the pre-AP or 10th grade honors level. We're going to jump into the predicting of double replacement reactions. Sometimes they're called double displacement or metathesis, which I can't really pronounce real well. But we're going to call them double replacement because one anion is going to replace another anion and cations replace cations. All right, now when you start these, strong suggestion, write the charges up above the species, and that's going to help you make sure that you're doing the proper exchange. So not only that, it'll help you with your, if you do this right, it'll help you. Oh man, if we don't know our polyatomic ions, what's the phrase, kiddos? You got it. All right, so that's nitrite, not nitrate. We're going to assume all of these are in solutions as reactants unless specified otherwise. So I've got tin 2 fluoride. Now remember, we have to have a driving force for a chemical reaction to occur. So let's see what that driving force is. I've got to put my positive with the opposing negative and cations with the opposite anion. So follow your formula writing rules. I'll get Kf and SnNO2 2. All right. Now, the question is, which one of these is our driving force? We didn't form a pure liquid like water, so we must be forming a solid, making this a precipitation reaction. And all group 1 salts, look at your solubility rules, all group salts are soluble without exception. So that means that's our aqueous and this must be our solid. Double replacement or never redox. Okay, let's try this next one. All right, so I've got calcium phosphate, and it says these are the products of the reaction, and I'm going to run out of room a little bit here, so I'm going to write it this way. I've got calcium phosphate. Either way, you're still replacing cations with anions, and I've got aluminum bromide. Now, if you look at your solubility rules, you'll see that this is aqueous and this is solid. Now, it is possible to form 2 solids, so look carefully at your solubility rules. All right, this is a precipitation reaction, and just like what we did before, opposing cations with the opposite anions. So I must have started with calcium bromide and aluminum phosphate. We're going to assume that that's in an aqueous solution. All right, just because the problem doesn't tell us otherwise. Now, one thing I neglected to do on the last one, and you always want to go back and do a double check before you leave the page, did you balance? And my answer for that one was no. And for this one, I need to balance. And let's see, that gives me 3 calciums, 3 calciums, 6 bromides, 6 bromides, 2 aluminums, 2 aluminums, 2 phosphates, 2 phosphates. It's balanced. All right, let's take a look at this next one. Hydrochloric acid, hydroic, came from ide. Ide is a binary single anion acid, is mixed with calcium hydroxide. Now, you've got a good hint that if we have an acid, we're dealing with a neutralization. But let's check to make sure we have a base. A hydroxide is a base. We're going to learn more about those later on in the semester. So our H is our positive, our chloride is our negative, calcium's +2, hydroxide's -1. So we must make a salt. Neutralizations always make a salt plus water. And the formation of that water, that liquid water, is our driving force for this neutralization, and no double replacement or never redox. Now, if you wrote your water as HOH, I'm not going to mark off on you for that. That's especially helpful to do that when water is a reactant for these. All right, let's forge through to some more of these. Just to give you we want to give you a broad range of the types of double replacement that we can have. All right, so here's another one. We've got sulfuric acid. Remember, ick came from ate. I ate something icky. So that's sulfate. So sulfuric acid is H2SO4. Potassium. Potassium's +1. Hydroxide's -1. So KOH. So it looks to me like I have an acid and a hydroxide. A hydroxide is a base. So I'm dealing with a neutralization. The H plus of the acid is going to go with the OH minus to make our driving force of water formation. It's a pure liquid. That makes K2SO4. And let's make sure we balance. I might have forgotten to balance that last one. So make sure you balance that last one before you show me your notes. So I need 2 of these, and I'll make 2 waters. All right. And that's double replacement. I know that was quick, but we'll have lots of time to practice these in class with me around to help you out, and you'll help each other out too. I love that. So this is, in the meantime, your beloved chemistry teacher. Love you guys. Take care.